All right, so here we have an example where we're using a conjunction of different rules. And so we have this function k of x here, and k of x is 3 times h of x plus x squared times g of x. And so it says to find k primed of x. So what I'm noticing here is that we have a function that has a coefficient there, or a constant multiple, right? And then we have a product here, and we have a sum. All right, so we're just going to use all those. So constant multiple, that just, if I take the derivative of this, and let's start with the sum. So first, if I take the derivative of the sum, I can just take the derivative of this independently and the derivative of this independently, right? So the derivative of that is just 3 times h primed of x, right? So we can just take the derivative of the function, then multiply it by the constant, right? That's the constant multiple rule. And then plus, and now I'm going to take the derivative of this. So this is where the product rule comes in, right? So I'm going to think of this as f, and this is g appropriately, right, since it is g. So that means I'm going to have f prime, I'll write this in pink here. So I'm going to write f prime g plus g prime f. All right, so f prime is going to be 2x, right? The derivative of that is going to be 2x times g, so it's just going to be times g of x, plus g prime, which is just going to be g primed of x, times f, right? And f is just x squared. Okay, and that's really it. There's not really any like terms here that we can combine, so that's really as far as we can go. Okay. All right. So just being able to apply our rules and just know how they fit in context is something that you'll see. And this isn't a super long or time consuming problem. It's just a matter of just understanding that, once again, how to apply the rules, right? And so if you have these where they give you h of x or g of x or f of x, then remember that you don't have to necessarily know the value of it or even the algebraic expression that it represents. You can just write it in these terms, right? H primed of x or g primed of x, or just regular g of x. All right, now let's talk about, let's see this one here where we're extending the product rule, where we have a product of 3 functions instead of just a product of 2. And so let's find k primed of x. All right, and so basically, let's think of this as, let's call it m of x, right? So if I have f of x times m of x, what I'm going to do is it's going to be f prime times m plus m prime times f, right? So the derivative of f is f prime, so that comes first, and then I'm just going to write regular m, so it's just going to be g of x times h of x, right? So this is m right here. Plus, now I'm going to do m prime, so now I have to take the derivative of this. So the derivative of that is its own product rule, right? So it's going to be g prime h plus h prime g, right? And then regular f is just f of x. All right, so now let me just distribute. So I'll distribute this here and this here. And so I'll have this first big term here, f prime times g times h, and then plus, and so this one I'm going to have g prime, h, and f, right? So it's going to be g prime times, I'll put f second, times h. And then last but not least, we're going to have h prime times g times f, right? So it'll be h prime times g, or let's put f first, just I'll go times g. Okay, so basically it's pretty much the same thing. We multiply the derivative of one times the other two, then the derivative of the next times the other two, and then derivative of the last times the other two, right? And this can be expanded for as many terms as you want. It's pretty much the same thing, okay? All right.